Hello all and welcome back. So up till now we have actually understood time complexity a lot in depth with all the asymptotic notations as well as done a lots of questions, right? So now I want to shift our focus on finding the time complexity of recursive algorithm. Now recursion is of course something which you have already studied a lot in depth. So to find out how the overall complexity with respect to input depends for a particular recursive algorithm, we will be using some different approach. That is something which I want to showcase to you now. So let's get started. For recursive algorithm, we use a different approach. Now again, we have many methods for this particular approach for finding out the overall time complexity of recursive algorithm. I'm going to teach you the one which is the most intuitive and which you can easily explain to your interviewer as can get the answer. That is actually something which you have already used. So recurrence relation method. Right, so we are going to use the recurrence relation and then find out exactly what the overall complexity is. There are other methods as well, such as master theorem, Akrabazi methods and everything, iterative approach as well, where you change your recursion code to iteration code. But again, I have found that these are not that intuitive, plus a lot heavy in maths. This is the one which you can actually explain very nicely to someone as well and be very comfortably be able to find out the answer, right? So let us begin everyone and let us take an example of factorial of a number, some code which we have done using recursion. So let me write this down as well, factorial of a number, right? Now when we talk about factorial, and let me write down the recursive code as well for the same, okay? It's going to be something like this. So I'm just writing a code which is kind of, we have written pseudo in nature. So the good thing with Python overall is that it is very close to your pseudocode as well. So return 1, right? And then we used to return n into factorial of my n minus 1, right? So this is the case. Now again, if you will see here, it is of course difficult to think how exactly are we going to find the complexity, right? What exactly is going on, because here if you will see what we are doing based on the approach which we have as of now covered, we are doing some k work here, we are maybe doing some k2 work here, okay, and we are not running any loop, we are actually not doing anything properly, and this we are calling the factorial n minus 1 directly, right? So the approach for this is that we will actually have to go inside this factorial n minus 1 and see that okay, what work it is doing. Okay, so we have to find out the work because this is kind of disguised, right? If you remember when I taught you recursion, multiple functions are made, just that we are not able to see them, and I explained that I am able to show you that in the Python tutor as well, right? So in this approach, with the light of this approach, we have to get inside this factorial of n minus 1 to see how it is exactly working. If we are able to debug that, if we are able to actually debunk exactly what is happening there, we will be able to find the same, okay? So the easiest way or the most intuitive way for that is something which I always ask you to write for any recursion question which you are doing, is to write the recurrence relation. Now, if you will see what I can write, okay, with the help of that recurrence relation. So recurrence relation used to be something like this. Factorial of n is equals to n into factorial of n minus 1, right? So now pay attention, what I'm going to do is that I'm going to derive the time equation from overall this recurrence relation. If I say that time taken by my factorial for a number n, for an input n is equals to tn, then what I'm exactly doing is I'm first doing some k1 work. So let us call this k1, right? Let us call this k1, and then I am doing some k2 work, which is the multiplication. Plus I can say that okay, apart from that I am doing one more work which is dependent on my smaller problem, right? So having the overall understanding about your recurrence relation is very important if you want to write a logic like this. What I've done here, I will repeat. The overall time complexity of my function for an input n, I have expressed as a time complexity of input n minus 1 because that is what is happening in my code, right? if you see this code, we are not running any loop, we are not doing anything, but this particular function is not free, it is actually doing some work. Okay, we have to calculate the same thing. Now once this is clear, okay, again we have to find this equation with respect to the time. So I am assuming that, let's say if this whole thing for an input n takes t of n, like let's say the complexity is t of n, then I am doing some constant operations and it is then dependent on t of n minus 1. Okay, so I hope this relation is a lot clear, everyone. So now let us expand on this relation to see how it can help us to actually derive our time complexity. I'm going to write the relation again. T of n is equals to, let me just wait, k plus t of n minus 1. Okay, so how come is this k? So I have just combined both of these works, these individual works. I have, let's say, combined in two and say this is a bigger constant k because they are constant, right? So let us go back. Yeah. Cool. So I'm doing some constant work, and whatever work my t of n minus 1, the small problem is doing, I just have to make sure that I also I'm also paying heed to that and making sure that I'm taking that into consideration as well. Nice. Now in this relation, I can of course change my n, substitute my n with n minus 1. So it's going to become t of n minus 1, right, is equals to k plus t of n minus 1 minus 1, which of course I think write by n minus 2, right? So it's going to be n minus 2. Okay, everyone. So I hope this is clear. Now if that can be done, then of course I can change it to, I can assume, I can just replace n with n minus 2 as well, and it's going to become t of n minus 3. Now if I continue this thing, you will also notice one thing, that this is just the work which is done by t of n minus 1. Now this is just the work which is done by t of n minus 2, right? So that's how my overall time relation is going. One thing which I would like to have your focus on is that what if my n is 0, right? N is 0, right? In that case, we will notice that we are just doing some k work, right? We are just returning it directly. We are not doing anything else. We are just returning it directly. So now what I can do is, if that is clear, so I will repeat what I'm saying. If in case when n is equals to 0, I'm not going into this part. I'm just returning. I'm just returning directly. I'm just doing some k work. It is now not dependent on my smaller output or smaller recursion call, right? Great. So everyone, I hope the recursion part is a lot clear. Please make sure that you have seen those modules. Okay. Now, with that in mind, for t of 0, I can write it as k only. So k1 and k, I'm assuming that both are fine, right? So they are anyway the constant work, so should be fine. Now, if we add all of them, so what I'm going to do is I'm going to add all of them. So one thing more, the way we are going to add them, there's a property. So let's say if we used to have a is equals to b plus 5 here, and let's say b is equals to 5. Then when I used to add both of them, okay, it will become a plus b is equals to b plus 10. Now because there is an equal to, this is an equation, I can subtract b from both sides, right? If I do minus b, this will get cancelled, and I will surely get a 10. What I want to show you is that we can actually directly cancel this b like this because it is on the opposite sides, right? So this is how we used to do the addition. In a similar manner now, of course, if this is clear, then I can of course cancel this out. So let me just do one thing. Let me just use a different pen so that it is clear. Great. So see, I can just cancel this out. Sorry, it just draw the straight line. It should be fine. Yeah. I can just cancel these out. Okay, everything is going to cancel out. This t of 0 is also going to get cancelled out because in the diagonal, right, in this particular diagonal is where this repetition of my overall t is going to be coming, right? If this is clear, then at the end of the day, what I'm going to just left over with is t of n and a lots of k's. So k plus k plus k, lots of time. How many time exactly? I think it will be n plus 1 times. The reason for that, first, second, third, and I'm going all the way not till 1 but till 0. So it's going to be n plus 1, right? If that's the case, then I think I've gotten my time relation. So it's going to be T of n is going to be k into n plus 1, something which you have already seen. I can write it less than. First, let me just remove the constant. So if let's say I open it, it is kn plus k. For a very large n, this k will not have any value, right? So we can remove it, assume it to be 0. It's kn. Kn is now something which we have seen a lot of time. I can just write it less than k plus 1 and n. And if this is clear, then I can surely write that time complexity of factorial is O of n, that is linear. Just understand one thing here, we are not given any list or array which is of size n, but still the time complexity is dependent, because in a way, if you understand the iterative approach as well, we will have to write a loop which starts from 0 or 1 and goes all the way till n. In a very similar manner, the function calls, the work which is being done, it is dependent on n. It is not some constant work which we will be doing. Okay everyone, so I hope this is clear. Please make sure that you understand this. This is a very good and intuitive tool. I have just actually explained you all the things from scratch so that you don't have to remember anything. This particular approach is lot useful, okay, and works in lots of cases of recursion based solutions. Using this, you can also explain it very easily to anyone, right? So that's why I have particularly make sure that you are able to understand the same. So yeah, that is all we find for the recursion. So let's move forward and do some more problems in the next video. Thank you.